Hi everyone, welcome to my channel. So in this video, I'm going to discuss the implicit differentiation. So by using the implicit differentiation, find the dy dx for the function xy plus cos 2x equals to x squared multiplied with the y squared. So we have the situation xy plus cos 2x equals to x squared multiplied with y squared. So kindly focus on the left hand side where we have xy. It is a multiplication, so meaning that we are going to use the product rule. So let the x as a u and y as a v. So the situation will be v multiplied with u prime plus u multiplied with v prime. So let's begin. So where we will have y multiplied with 1 plus u, where we have x. Then if we differentiate the y with respect to x, and we have dy dx. Next, focus on the cos 2x. If we differentiate the cos, we will obtain negative sine 2x. Kindly focus on the internal function. Differentiate the 2x and we will obtain 2. Next, equals to, again, we have a multiplication, so meaning that product rule is applied. So where we have u, then we have v. So the situation will be the same, meaning that we will have v u prime plus with u v prime. So let's begin. V, where we have y squared, multiply with the u prime, meaning that you have to focus the x squared. Differentiate the situation, we will have 2x. Plus, we have x squared. Differentiate the v, which is y squared. So meaning that we will have 2y dy dx. Because the term is not x, it's a y. So meaning that we have to add on the dy dx. So kindly rewrite the situation. Y plus x multiplied with dy dx minus 2 sine 2x equals to 2xy squared plus the 2x squared y dy dx. So rearrange the situation. X dy dx minus 2x squared y dy dx equals to 2xy squared plus 2 sine 2x minus y. So factor the situation where we have dy dx multiplied with x minus 2x squared y equals to 2x y squared plus 2 sine 2x minus y. So finally, dy dx is equals to 2xy squared plus 2 sine 2x minus y over x minus 2x squared y. Hi everyone, welcome to my channel. In this video, I'm going to discuss the example for the parametric differentiation. So given the parametric equation, x is equals to ln bracket t squared minus 1 and the y is equals to ln bracket t plus 1 to the power of 2. Find the second derivative when t is equals to 2. So now, kindly rewrite the situation where we have x is equals to ln bracket t squared minus 1 and the y will be equals to ln bracket t plus 1 power 2. By using the properties of log, we can bring forward the 2. So where we will have y equals to 2 ln bracket t plus 1. So now we are going to differentiate the x with respect to t. So dx dt is equals to 1 over t squared minus 1. Do remember to differentiate the internal function and we will have 2t. Rewrite the situation. So dx dt is equals to 2t over t squared minus 1. Next, focus on y. Differentiate the y with respect to t, and we will have 2. Differentiate the ln, and we will have 1 over t plus 1. Do remember to differentiate the internal function, and we will obtain 1. Rewrite the situation, dy dt equals to 2 over t plus 1. Next, we are going to find the dy dx. So, the formula would be dy dx equals to dy dt multiplied with dt dx. So, kindly substitute the situation where we will have 2 over t plus 1 multiplied with, do remember to flip the situation, where we will have t squared minus 1 over 2t, and we can simplify the situation. So kindly factorize the t squared minus 1. So we will have the dy dx is equals to t minus 1 multiplied with t plus 1 over, we have t plus 1 multiplied with the t. So finally, dy dx is equals to t minus 1 over t. And dy dx can be simplified as 1 minus 1 over t. Next is to find the second derivative. So before we begin the discussion, so kindly state down the formula for the second derivative, where we have the differentiate the dy dx with respect to t. Kindly refers to dy dx. We notice that the dy dx is expressed in terms of t. That's why we need to differentiate the dy dx with respect to t. Then do remember to multiply with dt dx. So let's begin the discussion. Differentiate the dy dx where we have 1 minus t to the power negative 1 with respect to t, and then multiply with dt dx where we have t squared minus 1 over 2t. So differentiate the situation and we will obtain over t squared. Multiply with t squared minus 1 over 2t. Simplify the situation. So the second derivative will be equals to t squared minus 1 over 2t cubed. So kindly refers to the question. The question asks us to find the value for the second derivative when t is equals to 2. So now we have the second derivative equals to t squared minus 1 over 2t cubed. Substitute the value of t, which is equals to 2, and we will have 2 squared, which is 4 minus 1 over 2 multiplied with 2 cubed, and we will obtain 8. Simplify the situation, we will have 3 over 16 for the second derivative. Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share and subscribe.